look at another example of a problem where we have to figure out what the steps are involved in these reaction processes. So we've got C3H8 plus Cl2 gives C3H7Cl plus HCl. That's our reaction. We're told that the rate equals K, C3H8 and Cl. That's not Cl2 there, that's Cl. So what does that tell us? Well, based on the information, can you say whether the reaction is one step or more than one step? We know it's more than one step because not everything that's in here is involved in the rate equation. So rate equals K, C3H8 and Cl here. So not all the reactants are involved in the rate equation. There's no mention of Cl2 here. However, if it had been one step, it would look like that, C3H8 and Cl2. So then it would be possible for this to be one step if this were everything that was involved in the rate equation. Alright, so that's the first two questions answered. Now let's look at a plausible reaction set. Now one thing I really haven't talked about yet is deciding whether or not the slow step is the first step or some other step in the reaction. Well, let's go back to the previous example. That's this one here. What you can see is that I've included the slow step as being the first step. Alright, so that's the slow step there, right there. And we knew that this one is we know that this one's a fast step. Alright, so the slow step, remember, we pull directly from the rate equation. The rate equation tells us it's KNO squared, which tells us there's two NOs involved in the slow step. But notice that the slow step is the first step in the process. Now the reason I can do that is because I can see that there are indeed two NOs in the actual reaction itself. So I can pull everything that's in the rate equation out of the reaction, which means that the slow step can indeed be the first step. Let's contrast that with the one we've got over here. Now what we've got is C3H8 and Cl, and in here we've got C3H8 and Cl2. Now what that tells us is that, yeah, I can pull the C3H8 out of the reaction for the rate equation, but what about the Cl? Now there's no mention of Cl here, but there is Cl2. So what does that tell us? It tells us that the Cl must come from the Cl2, which means that this cannot be the first step. It would have to be some kind of other step other than the first step. So what I'm going to do is I'm going to write this down in the middle here because I know that it cannot be the first step. And that's my first piece of information. I know that that is the slow step. And again, I know it's a slow step because the slow step always comes from the rate equation, C3H8 and Cl. So I know that the C3H8 is going to is okay. That can be pulled directly from the reaction, but the Cl had to come from somewhere else. It's coming from the Cl2. It certainly can't come from the C3H8. So what I'm going to do is come up with something that allows me to get the Cl. So Cl2 can give Cl plus Cl. Well, let me tell you the difference between Cl2 and Cl plus Cl. Cl2 is a molecule. It looks like that. It's two Cl's joined together. Cl and Cl separate are Cl atoms. So that's the difference there, and that's why you shouldn't get confused between them. Alright, so we've gotten that under control. Now, as a general rule, if you can form one of these products, you should. And I can form one of these products out of this reaction. I've got C3H8Cl, and what I'm going to do is I'm going to make that into C3H7Cl. I'll do that because I can. So it matches this down here. I know I'm going to have to get this at some point, so I may as well try and get it from this reaction. So I do that, I get C3H7Cl, and what's left over? Well, I've already used up the Cl, and the only thing left out of that would be an H. Not an H plus, not an H minus, just an H. Remember, this all has to still balance for charge. There's nothing charged here, so the Cl's here aren't charged, so all we're left with is just an H, and that all balances out. Now you've got 3 carbons, you've got 8 hydrogens here, that's 7 plus 1 is 8. We've got 1 chlorine and we've got 1 chlorine here, so that's good. So now we've accounted for this, and that's good. We've accounted for C3H8, we've accounted for Cl2. What we haven't accounted for is the HCl. And I think you can see that if I want to form HCl, I can take the H I formed up here and react it with the Cl that we haven't used up here, and that'll give us our HCl down there. So that is a valid reaction set for that particular process. That'll be fast, and this will be fast as well. So any step that's not slow is going to be fast. Alright, so remember that if we formed H here and there's no H anywhere in the reaction, that signals us that we can bring it down and make it a reactant in some other step. Indeed, we have to, because we have to react it to get rid of it. And it's going to react with the Cl that we didn't use up here in the previous step. So that would come up with a valid reaction setup for that particular problem.